Okay, so like I said at the end of video number 2, I actually wanted to go back and read you questions 20 and 21, because if you go into where we're at in lesson 42, lessons 20 and 20, or sorry, questions 20 and 21 are actually combination questions. And so we have a formula for doing these types of questions. What I'm going to do is I'm going to actually open us up into there we go. We're going to scroll down past this, and we're going to work out some of this down here. All right, so in a combination question, you can go back and look at your own and see what it says, but I'll read it out. Pat has 5 flower pots. She wants to plant a different type of flower in each one. There are 7 types of flowers available at the garden shop. And how many different ways can she choose the flowers? Initially, the way that I taught this wrong is supposing that there are 1, 2, 3, 4, 5 flower pots. 7 could go in the first one, 6 the next one, 5, 4, and 3, and then taking that on down. That was giving us a number in the thousands of place. What you have to remember about this is that we're really looking for a much smaller number because out of those 5 flower pots, it really doesn't matter which one goes into which pot. We're just looking at how many different ways can she pick 7 different flowers if she can only pick 5. And so that's a combination question, and combination questions use a formula that looks like n factorial over the number that we're taking at a time, which is r factorial times my number minus the number I'm taking at a time factorial. And so the way we put these numbers into this particular question is we're actually taking the number of flower options, which is 7. And how many we want to take at a time? Well, because we're leaving 2 out, because if we're picking 5, we're leaving 2 out every time. So my combination number, or my R, is actually 2 factorial. So we're going to set it up like this. So it looks like that. Now, we can plug this in our calculator and see what it looks like. If we were to do this just pencil paper, we are going to get 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 times basically 7 down 5 places, and going on actually 5 factorial instead. So I'm going to show this on how we can do this in our calculator here, and we're going to actually try to do a good job with parentheses, but this is what we're typing in. We're going to do 7. We're going to hit math. We're going to go over to probability. We're going to go down to 4 and get our factorial. We're going to close our parentheses, and we're going to divide by this whole thing down here. So we're going to go 2, math, probability, down to my factorial, another set of parentheses for my 7 minus 2. Okay, close that up, do my math, do my probability. All right, close up my final set of parentheses, and that's where I'm getting the number 21. Rather than this great big number that goes, I think, something like 2,000. Okay, we don't need nearly that big a number because there's actually 21 different ways in which we pick 5 and leave 2 out. Okay, so our formula that we want to use for this is that one right there. And you can find this in your book on page 306 if you want some other examples. You can look through the examples in lesson number 42. And so in question number 21, it's actually fairly similar. Okay, we're going to extend our page and extend it a little bit more, so we'll have to create a new page for it. Okay, and question number 21 says the school debate coach must select a group of 10 from the 11-member team. So 11 is my factorial. Okay, and because I'm leaving one person out, I'm deciding how, there are, really this is a much simpler question than even working it out with the formula, because I'm taking one person out every time. So I'm really getting 11 minus 1 here and closing that up. But really just, once we understand how combinations work, we understand that we're only leaving one person home, no matter which 10 we pick. So there's only 11 possibilities, because in any possibility I'm leaving one person home. So I can leave any one of those 11 people home. So if you plug this in your calculator, you should still get the number 11. Okay? Yes. Okay. So I'm going to go back to our review here. We're going to come down to question number 22. Both 21 and 20 come from the same lesson 42. Both of them use the same formula, so it's part of what we'll look at. Question number 22 says find the value of sine, cosine, and tangent functions of theta, where a equals 66, b equals 112, and c equals 130. Unfortunately, the triangle does not all fit in the picture. So let's go ahead and put the rest of that in here. A is 66. We've got theta right here. Let's see, let's cut that out. We've got A, and this is angle A. Okay? For theta where A, and B would have to be this angle right here because its side is 112. Okay, and C has to be here because the hypotenuse is the longest side of the right triangle. Okay, so we've got 66, 130, 112, and we want the sine, cosine, and tangent functions of theta. Sine is opposite over hypotenuse, so my hypotenuse in this part is 130. Okay, and opposite of theta, which is angle B, is 112. So we're going to simplify that down. What's 130 divided by 112? Should be 65 over 56. And I know I've got some Algebra 2 students in here, so if I need a calculation, if you guys can help me out, I really appreciate it, okay? All right, let's see, we want the cosine. Cosine is adjacent over hypotenuse, so adjacent to theta is 66. My hypotenuse doesn't change, so that's 130. What's 66 over 130 reduced? About 33 over 65. Okay. All right, and tangent is opposite over adjacent, so it'd be 112 over 66. Okay, opposite of theta is 112. Okay, and adjacent to theta is 66. What's 112 over 66? 33. No, 56 over 33. 56 over 33, that's what I said. 56 over 33. Now, as I'm looking at the answer key here, they've got their sign mixed, which has to be wrong. So if you're looking at your answer key on number 22, it should be 65 over 56. Oh, hold on. No, I was wrong. I'm sorry. That because sine is opposite over hypotenuse. That's what I'm saying. So we should be getting 56 over 65. Be careful with that. Okay. So those are our three trig functions for that. Again, I wish that the triangle was a little bit bigger, but hopefully we can make good sense out of that. All right. Number 23. Number 23. Okay, we've got a complex fraction. Okay, on 22, if you want to find out where you would look that stuff up, that'd be lesson 46, finding trigonometric functions and their reciprocals. Number 23. Lesson 48, understanding complex fractions. We're going to look at this as two separate units. I've got a fraction on top and a fraction on the bottom, both of which need to be simplified. So I'm going to take 17 over a plus 4 over 1. Anytime they give me a whole number and I want to add it to a fraction, I'm going to make that a fraction over 1. My common denominator is going to be a, so I'm going to multiply 4 over 1 by a over a. That's going to give me 17 plus 4a. over A. That is my numerator, and that's as simplified as it's going to get for now. Now I'm going to do the same thing for B. Okay, I've got 5 over B plus 7 over 1. Common denominator here is going to be B over B. Yeah, let's go ahead and turn that down. Thank you. All right, so we got 5 plus 7B over B. Boy, I get all kinds of interruptions.
Katie Banner, Emily Castro, Benadu, Miyasi, Courtney McCollum, Leslie Martinez, Marcus Diaz, Bill, Will Pacheco, Brett Sayer, and Austin Ziegler. Again, please report to the cafeteria at this time. Thank you.
Okay, so pardon that interruption there, but what we're going to do is we're going to multiply by the reciprocal. So I'm going to take 17 plus 4A times B. Okay, we're going to distribute that. So then I'm getting 17B plus 4AB. Right, and I'm going to multiply A and distribute that to 5 plus 7B. So I get 5A over plus 7AB, and that is as reduced as that is going to get. So they're really, and it's the same rules, everything's applying the same way. It's just a little bit more abstract because we're talking about solving complex fractions in algebra where we're substituting in. Of course, we're dealing with some variables in here. Okay? All right, number 24 has us use Pascal's triangle to expand. All right, so I'm going to move on to another page here that we can look at so I can show you what Pascal's triangle actually looks like and hopefully explain that a little bit. All right, Pascal's triangle is going to start with 1 because anything to the 0 power is 1. We're going to square it. We're going to get 2 terms that are just themselves. 3, we're going to get 1. You know, our outside terms are always 1. And when we get to this point, we're going to add the terms above it. So 1 plus 1 is 2, and then we get 1 on the outside. Okay, if we go to the 4, I think at this question, let's see what question I am here. And I have question number 24. Okay. Let's see, so we got 1 here. 1 plus 2 is 3. 2 plus 1 is 3. And 1 on the end. Notice that these work as a palindrome. They're going to go up. They're going to come down the exact same way. Okay. And because we're 2 to 4, and my original equation was 2x plus 6 to the 4. What these numbers here is we're looking for 4 because this is a 4. Okay? These numbers here are going to be my coefficients of what I'm going to use. So as we set this up, it's going to look like this. I'm going to take 1 times 2x to the 4 times 6 to the 0. Okay? And I'm going to close all of that up. It's going to look like that. And that's one single term, okay, that goes for that right there. Okay? You'll notice that my first one, that 2x, is going to have the highest exponent. And my second term, my 6, is going to have the lowest exponent it could have. Their exponent should always add up to the exponent that I'm looking at, which is, in this case, 4. Okay? After that's all done, I'm going to add, and I'm going to move on to the next one. Okay? Which in this case, the coefficient is 3. Okay? So I have 3 times 2x, and then it's going to go down 1. So it was 4, now it's going to be 3, and the next one is going to go up 1. So 6 to the first. Okay? That's going to end that. Plus, then we're going to look at our next coefficient, which still happens to be 3. I'm going to do another parentheses. So we're going to use that 3 there. 2x. We're going to drop down another exponent, which is 2. And then 6 squared. Okay? You'll notice that we went 4, 0, 3, 1, 2, 2. All of those are going to continue to add up to 4. Our last one is going to look like this. We're going to use 1 as our coefficient. And let's try to stay consistent with the color. And then 2x. Let's see if I can do that right. Ooh, we made a big mistake. I made a great big mistake. I don't know if anybody caught this, but I made a big mistake in setting up my triangle. Because we skipped 1. 1, 2, 3, we need to go one more down. 4. Okay? Outside number is 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then 1 on the outside. Alright, that's embarrassing. Okay, so we're going to start with 1 again. 1. Okay, we're going to get that 2x to the 4th. So some things won't change. We're going to get 6 to the 0. Close that up. Plus, this one's going to be 4. 2x cubed. 6 to the first. Okay. Plus 6. 2x squared, 6 squared, plus 4, 2x cubed, 6, let's see, actually, nope, we made a mistake there too. That needs to go down another. Okay, so that should be first, 6 to the 3rd. We're running out of space. Let's drop down a little bit and let's get our final one. Plus. We're going to slide in there like that. Okay, so we've got 1, 2x to the 0, plus, times 6 to the 4. Alright, our final step in here is we want to go ahead and solve this. Okay, so this one right here. Alright, we're doing 1 times, so that's not really going to change anything. Neither 6 to the 0, 6 to the 0 is still 1. 2 to the 4th though. Okay, 16. So it's going to be 16 x to the 4th. Okay? That's it. 16x to the 4th. Plus our next one. So we're going to get there as we're looking at 2. We're getting 4 times 2 cubed times 6. 4 times 2 cubed. Well, 2 cubed is 8. So we have 4 times 8. 4 times 8 is 32. What's 32 times 6? 192. 192 x cubed. Plus, now our next one is 6 times 2 squared times 6 squared. So that's going to be 6 times 4 times 36. 144. And notice that that's x squared. I'm going to come down again. You guys okay? Okay. Alright, our next one is 4 times 2 to the first, which is just 2, so we've got 8. Times 6 cubed, which is 216. 216 times 8. 1,728 x. Alright, now we have 2x to the 0, which is just 1. 1 times 1 is 1. Plus 6 to the 4th. What is 6 to the 4th? 1,296. Let's check that answer key and see how far off we are. Let's see. This is number 24. 16x to the 4th plus 192x cubed plus, I see 64x squared, 1,728x, 1,296. So it looks like the only thing that we might have messed up on here is this guy right there. Let's go back and check that. That was my third term. Alright, so I'm going to recalculate that. 6 times 2 squared plus 6 squared. 6, 2 squared, 6 squared, 864. Alright, so 864x squared should go in right there. Okay, so there's a lot there. It's is, like I said, take it one step at a time if you get a question like that. You're more than likely to get a question that's just going to ask you how many terms are there if I take this to the fourth. You're always going to get one more term than you have an exponent for whenever you're doing Pascal's triangle. So on this question, we should get 5 terms. And if I look at those, I notice 1, 2, 3, 4, 5 terms, even though we were taking it to the fourth, which matches with 1, 2, 3, 4, 5. Okay. Let's look at another question, number 25. We're kind of struggling with some of our radical questions. Notice that. Are irrationals. So if we've got this, one of the things to remember is that we're going to solve these by multiplying by the conjugate. The conjugate is the opposite sign in the denominator. On top and bottom, we're going to multiply. So if I've got 4 plus radical 2 over 2 plus radical 2, then I'm going to multiply both the top and bottom by 2 minus radical 2 over 2 minus radical 2. From there, I'm going to FOIL and simplify. So 4 times 2 across the top is 8. 4 times negative radical 2 is negative 4 radical 2. Radical 2 times 2 is 2 radical 2. Okay? And radical 2 times negative radical 2 is negative 2. Okay? We can simplify that so that we get 6 minus 2 radical 2. And then we've got the bottom to solve yet. So there, we're getting 2 times 2 is 4. Don't know how well you can see that. And because it's a sum difference, I only need to do two outside terms. So radical 2 times negative radical 2 is negative 2. So I've got 6 minus 2 radical 2. 4 minus 2 is 2. I'm going to divide both of those terms here and here. So I'm getting 3 minus radical 2. Let me check my answer here and make sure that we're right. This is question number 25. 3 minus radical 2 is our answer. If you want to know where we're at on question number 25, question number 25 comes from lesson 44, rationalizing denominators. Okay? Are you guys doing what you're supposed to be doing? Because if you're not, I'm going to pause this. I'm going to chew you out. Okay? Because you guys are being a really big distraction. All right, number 26. They solve the inequality. 2t minus 5 is greater than negative 9, and then graph the solution set. What you want to do with any of these inequalities, just like in anything else, is that you want to isolate the variable. So we're going to add 5 to either side. It's going to give you 2t is greater than negative 4, divided by 2 on both sides. T is greater than negative 2. This is 0, negative 2. And we're going to get an open circle because it's not equal to, and we're going to go to the right because we're greater than. Okay, that looks like it should work for 26. 26 comes from lesson 10, solving and graphing inequalities. Okay, 27. 27 comes from lesson 11, understanding polynomials. This is really a matter of combining like terms more than anything else. Notice that we see this plus in between here. If that's a negative, I would have to distribute that negative to everything inside the parentheses on the right-hand side and then combine like terms. That's the number one mistake that's made with these. All right, so from here, we can either rewrite this or we can just be careful as we go. I'm going to choose to be careful as we go. I'm going to look at negative 5x cubed and see if I have any like terms. I don't, so I'm going to leave it as negative 5x cubed. Next thing, I'm going to look at my x squared. I see that I have a negative 1x squared and a negative 3x squared. That's going to give me negative 4x squared. Okay, so far we've gotten rid of this one, and this one right here. All right. Let's see, what do we got next? We've got our x's. So we've got negative 4x and positive 9x. Negative 4 plus 9 is positive 5x. Okay, that's going to get rid of this guy and this guy, leaving me only with negative 6 as my answer. There's really nothing left to do there. Negative 5x cubed minus 4x squared plus 5x minus, sorry, we did miss one. My mistake. There was a 3 here, so we've got negative 6 minus 3, so we should get negative 3 right there. Okay? So try to be vigilant and observant about what all we're working with. So that's why I like to write things down and cross things out once I'm done with them. And that way it gives me an opportunity to look and see if I left anything behind before I move on. Question number 28. So I'm going to erase this work here. And slide it over so we can see the rest of it. Okay, question number 28. Question number 28 comes from lesson 12, solving inverse variation problems. It says a centrifugal acceleration, or AC, of an object moving along a circular path is proportional to the square of the object's velocity, or v squared, and inversely proportional to the radius r of the circle. What kind of variation is this? And write the equation. All right, like we said, this is lesson number 12, and because it is both, it includes both direct. Let's see if I can find out where I'm going to move this. It's inversely proportional to something, and proportional. Okay? It is proportional to the square, and inversely proportional to the radius. All right? This is what we call a joint variation. Okay? A joint variation. So we're going to go back and use the information that they gave us. They told me the acceleration, or A subscript C. Okay? The centrifugal acceleration of object moving along a circular path is, means we're going to get this equal sign here, is proportional to the square. All right, one of the things you want to include, because it doesn't say direct, we're going to put K out front. That's my constant. Direct variation, or proportional, goes on top. Okay, object's velocity. So I'm going to put v squared on top. And inversely proportional goes on the bottom, r. So that's what we see with a joint variation. You could probably go ahead and put that k up there with that v squared. It looks a lot like direct proportional, so you can have direct and inverse proportional in the same equation. Number 29, solving and graphing absolute values. Another one that we struggle with because we switched too early. If I've got x minus 8 is equal to 4, my absolute value is already isolated, so I'm going to write it as the equation as x minus 8 equals 4, and x minus 8 equals negative 4, and solve both of them. Add 8 in either case, so 4 plus 8 is 12, and x equals add 8 to the other side, and I get just 4. Okay, so if I was graphing this, I have 0 over here, 1, 2, 3, 4. Okay, it's equal to it. 5, 6, 7, 8, 9, 10, 11, 12. There's my graph. It's those 2 points right there. Number 29. That's what that looks like. I'm going to go ahead, and for now, I'm going to pause this. All right, so we're going to come back. We're back here with question number 30. Question number 30 is coming from lesson 20, performing operations with functions. So what we're doing is we're taking function f and we're dividing it by function g. Okay, function f is x minus 14, but notice that it says that we want to plug in 4 for x. So what I can go ahead and do is put in 4 minus 14. Okay. And we're looking at function g, and I can do 4 minus 13 down below. Now, there's two things you can do. This is what we call solving numerically. 4 minus 14 is negative 10. 4 minus 13 is negative 9. That's going to be 10 ninths. I'm trying to look at what the answer is on this question 8. You get 1 1/9, which is the same as what we've got is 1 and 1/9. Okay? There is another way to solve this if you want to do it. And that includes just solving it algebraically, which is x minus 14 over x minus 13. And you're trying to do it that way, but you're going to end up doing the same thing you're going to plug in 4 for x. So there's really no sense in doing that. But in some of the other types of function questions, you might want to solve it algebraically. Okay? All right. Let's go on to question 31. Okay, determine whether the graph is continuous, discontinuous, and/or discrete. Determine whether it's a function or relation. Determine the meaning of the range of the function. So take these one at a time. You can tell it's not continuous because there's not a solid line connecting them. It's more than just discontinuous. It is discrete, meaning that they're giving us a bunch of independent, unconnected points. Let's see. So we're discontinuous and discrete. And so we've got that. We've got discontinuous and discrete. You would write that down. Determine whether it's a function or a relation. Well, it passes the vertical line test at every point on the function. All right, so it does count as a function and not a relation. Now, if for some reason they had given me a singular point in here that had, say, existed right there, it would no longer be a function because it wouldn't pass the vertical line test at that point. Okay, but in this case, because they're in a horizontal row, not just because they're in a horizontal row, but because they pass the vertical line test, it is a function. Now, in terms of the domain is a set of x values. So my domain is going to be pretty specific here. Okay, my domain is negative 7, negative 1, 4, and 6. That's my domain. Okay, it's those very specific things. And you could say domain, you could say x equals. My range is my y equals. And y equals, in every case in this one that we're looking at, y equals 1. This is my range. Okay? Not wrangle, but range. Okay? So domain and range. So keep that pretty simple on this one. It might be more complicated on the test tomorrow. Okay, so be aware of that. All right, question number 32. Question number 32. Question number 32 comes from lesson 23, factoring polynomials. X squared minus x minus 30. Because it's an x squared, it's pretty handy because it allows me to put x in my first terms. They give me negative and negative, which means I have to have a positive and a negative, where the negative is going to be larger. It's going to be larger because I've got a negative in the middle there, which means when I add it up, I still get a negative number. I know I have to have a positive and a negative because it's the only way to multiply two things and still get a negative number. Because there is a difference of 1, I'm looking for multiplying two things to get 30 that have a difference of 1. Things that multiply to be 30, you could get 1 and 30. You could get 2 and 15. We could get 3 and 10. We could get a number of different things here. You could get 6 and 5. And 6 and 5 is what we're looking at here, where 6 is larger and 5 is smaller. So whenever I multiply those, I'm going to get x times x is x squared, x times negative 6 is negative 6x, 5 times x is 5x. Not negative 6x plus 5x is going to be negative 1x, and 5 times negative 6 is negative 30, so it doesn't work itself back out. I'm going to take each of those terms, I'm going to set them equal to 0, x plus 5 equals 0, x minus 6 equals 0. To find the solution here, I'm going to subtract 5 across, so x equals negative 5. And I'm going to add 6 across, I'm going to get x equals 6, and those are my two solutions. Okay? If you want to help there, like I said, go to lesson 23, factoring polynomials, to do some more practice questions. Question number 33. Question number 33. Let's see if I can find that here. Okay. Question number 33 comes from lesson 26, right? The equation of a line. The line has a slope 12 and passes through the point -5, -58. What's the equation of the line written in slope-intercept form? I have all the information I need to use y minus y1 equals m times x minus x1 for a point slope formula. I can plug in, it should plug in, y minus -58 equals slope. My slope here is 12, and tell me that, and x minus x1, so x minus -5. So be careful to make sure that we put in both negatives, and we're going to see, of course, that those are going to become positive. So we can rewrite that as y plus 58 equals 12 times x plus 5. That's simpler. So we're going to get y plus 58. Go ahead and distribute our 12, so we get 12x plus 60. Then we're going to subtract our 58 across, minus 58. So we get y equals 12x, and 60 minus 58 is a positive 2. That's my equation in slope-intercept form. Y equals 12x plus 2. Okay, we're getting right here towards the end. It's going to be a massively long video. I apologize. Number 34. For sake of time, I think, on this, we have seen this question solved. You can go back and look at that previous question. I'm trying to look and see if I can tell you what question number that was that we worked out. 100% sure. But you can go back. It's just a system of 3 equations with 3 variables. So what we did is we took our graphing calculator and we put those in as a 3x4 matrix. Of course, we'll be real careful as we do that. Then we're going to use RREF. So what it will look like, just so you know how to look nothing, is we want to have something like this: 3, -3, 3, -6. We'll get 8, 4, 1, -75, and 5, -7, 1, -26. Whenever I do that, I'm going to hit RREF, so it'll look like this. If you use matrix A and edit it, it's going to look like that, but it's going to shoot something out that's going to look like 1, 0, 0, 0, 1, 0, 0, 0, 1, and right here is going to be where those answers come out at. And I'm looking to see if those answers are in this question. Question number 34 comes out to -9, -2, and 5. So x is -9, y is -2, and z is -5. So that's going to look like. Like I said, if you have trouble with that, go back and look at the earlier, I guess we'll call it a tutorial on how to plug that in your graphing calculator and save yourself some time. Number 35 says graph 5x plus y equals 20 by solving y to obtain slope-intercept form. So let's go ahead and take that. 5x plus y equals 20. Let's put it into slope-intercept form like they say by solving for y. So let's subtract 5x. That's going to help me isolate y. So y equals -5x plus 20. So here we have a y-intercept, which really just doesn't fit on the graph. We got a y-intercept that's double what we would get there. And it's going down by 5. So as I look at this, it actually, the only thing that we really can get is our x-intercept. So if you go ahead and look back up here, this is a little trick. That if we want to find out where our x-intercept is, if our y-intercept is too high, then we can get our x-intercept. Our x-intercept is when y equals 0. I'm going to pause this for a second. Alright, so what we're going to do here is we're going to plug in 0 for y. So and that's 5x plus 0 equals 20. So I would end up taking 20 and dividing it by 5 to get my x. 20 divided by 5 is 4. So that tells me that my x-intercept right here is 4, and I can actually work my way back up to graphics. Because if you remember, my slope is -5, so I would be dropping 5 and going over 1. So I can actually go up 5, 1, 2, 3, 4, 5, and then back 1. So my next point would be there. Okay, and then go up 5, 1, 2, 3, 4, 5, and back 1. So I've got this position right here. So now I can actually graph that line, even though I can't represent the y-intercept on the graph given me because there's not enough space. All right, let's look at 36. Write the equation of a line that is parallel to the graph of y equals -5x minus 9 and crosses the point -4 and 4. The one thing we want to notice is that it says parallel lines have the same slope. So I want to continue to use -5x for my slope, and I can use y minus y1 as I have a slope, and I have a set of coordinates. So I can use m times x minus x1. So I'm going to use the coordinates they gave me right here. So y minus 4 equals my slope, -5 times x minus -4 from right there. So I've got y minus 4 equals, I'm going to distribute -5x, which is the positive, so -5 times positive 4, -20. Add our 4 over there. Remember, it's a -4 plus 4. Y equals -5x minus 16. Y equals -5x minus 16. This is lesson 36 using parallel and perpendicular lines. So I'm going to go over there and look at some other examples. Number 37, this comes from lesson 44, rationalizing denominators. We saw a question like this earlier. This is where we talked about multiplying by conjugates. Conjugate, again, is the denominator with the opposite operation. So we're going to multiply this by -7 minus radical 7 over -7 minus radical 7. The nice thing about that is that we're multiplying by 1 on top, so what I'm left with on the top is -7 minus radical 7. Nothing needs to change there. On the bottom, remember, because we're always going to end up with the sum difference, not only need to multiply by the outside term. So -7 times -7 is 49, and radical 7 times negative radical 7 is going to be -7. So I'm going to get -7 minus radical 7 over 42. And that's our final answer. We can't really simplify beyond that. That won't always be that easy, but in this case, it is. Our final question, he says, use the binomial theorem to expand. So if you remember, and actually I'll try to pull it up here if I've still got it, is our binomial, or sorry, our Pascal triangle. Now we took it to 4, but we can continue to take it on down further. So let's go ahead and do that. Let's erase some of this. Okay, so you can see, let's see. All right, so let's go ahead and take that on further, and we don't need this guy. We will need our own problem again. And this is going to be fairly large because we're talking about taking it to the 5th instead of just to the 4th. Okay? All right, we're taking this, and what we're using is f minus 6 to the 5th. So we need to the 5th, so we're going to come down here one more. We know we're going to start with 1 plus 4 is 5, and you'll notice that if this is 5, that next number is going to be 5. Notice 4, 4, 3, 3. So always tells you you're on the right one. 4 plus 6 is 10, 6 plus 4 is 10, 1 plus 4 is 5, and then 1. So these are going to be my coefficients. This go around. All right, so I'm going to start off with, I'm going to see if I can write a little bit smaller, but my marker is pretty big. So that's going to be 1 f to the 5th, -6 to the 0. You don't have to include that, but I want you to see where everything is going. Plus 5, there's my coefficient, f. to the fourth, because we're going down one, negative 6 to the first, plus parentheses 10, that, we're going to go down another, the third, negative 6, up 1, squared. Okay, plus 10, that to be down another, squared, negative 6, cubed. Now remember, those exponents should always add up to the exponent I originally used. In this case, it's 5 plus 5. F to the first, negative 6 to the fourth. And as always, I always seem to be 1 short plus. Let's see, we're at 1. F to the 0, negative 6 to the fifth. Alright, so as I'm trying to solve this, I'm going to try to have the calculator out and you can see it, but hopefully you can calculate this along with me. It's going to be different colors, so I'm going to keep some of them separate. 1 times f to the fifth isn't going to change anything. Negative 6 to the 0 is still 1. So I get just f to the fifth for that first spot. Now, following that, I have negative 6 to the first, which is negative 6. So I'm really getting 5 times negative 6, which is negative 30. So instead of a plus, we're going to use a minus. We're going to subtract 30 f to the fourth. Okay? And you'll notice that because of this, we're going to end up alternating between plus and minus because of that negative 6, and whether or not we're taking it to a positive or negative, or sorry, positive, even or odd exponent. So plus, and here I'm getting 10 times negative 6 squared. Well, negative 6 times negative 6 is 36, and 36 times 10 is 360. So that's positive 360 f cubed plus, now this next one is going to be the opposite. It's going to give me negative 6 cubed is going to be negative 6 times negative 6, which is positive 36 times negative 6, which is actually negative 216. 216, negative 216 times 10 is negative 2,000. 360 cubed minus 2,160. Let's see, f squared. Okay? And so if that was negative, the next one should be positive. And we're going to get negative 6 to the fourth. Comes out to 1,296 times 5. Which is the positive 6,480. That just half. Okay, and our last one, we got 1 times f to the 0. 1 to the 0, anything to the 0 power is 1, so that essentially 1 times 1 times negative 6 to the fifth. And negative 6 to the fifth is negative 7,776. Okay? So we'll get my answer here. Hopefully I've got it somewhere. Let me read it off here. It says f to the fifth, which we have, minus 30 f to the fourth, that looks good, plus 360 f cubed, got that, minus 2,160 f squared, good, plus 6,480 f, minus 7,776. That is lesson 49, using the binomial theorem. There's plenty there that you can look at that will help you out. Feel free to look up any additional YouTube videos on that. I'm sure there's plenty out there that will be a great help to you. Good luck. I know that there's a lot of video, a lot of time to take in looking at these videos to study for your test tomorrow. Do your very best, and I'll see you then.